welcome everyone, and sorry for the few minutes of delay in starting. So this is the BCS event and hosted by Manchester branch, and we've got the topic is digital twin or digital twinge, as Ian likes to call it. We've got really good speakers today. So Paul Yates from Toshiba is going to tell us about digital twin within railways. And then we've got Ian Gordon, who's going to tell us about digital twin in highways. So the first talk is going to be by Paul. He's going to talk about train planning and how digital twin is sort of started in manufacturing industry. It got, and believe it or not, it was first, I was reading about it today, it was first mentioned in a conference in 2002, in a manufacturing conference. And then since then, in 18 years, it's been used all across the industry, automobiles and different logistics, even NASA used it in 2010 for their space shuttles and stuff. For today's talk, the top one is going to be the use of digital twin within train planning. And Paul's got extensive experience in timetable planning, and he's currently helping Toshiba as a business consultant, transformation consultant for digital twin. So we'll see how digital twin is helping within the railway sector with timetable planning. Toshiba is sort of paired up with one of the train providers, and they're using digital twin to improve the timetable within the railway. And in the second talk, Ian's going to tell us about digital twin within highways. Ian is the head of data within highways, and I've personally known Ian for about 7-8 years now, and I know he's keen on cloud computing. Digital twin is his new sort of interest. Well, I say new, good few years now, 2 or 3. And more importantly, beers, craft beers. Okay, so without further delay, we're going to kick off the event. In terms of, we're not expecting any alarms. If there's an alarm, it's potentially at your home, so please do address it. But yeah, without further delays, let me introduce you to Paul, who's going to tell us about digital twin within the railway sector. Paul.
Okay, thank you. Thank you, Coldy. So yeah, my name is Paul Yates, and I work here in our nice offices here at Stockley Park in London today. And I'm a railway digital transformation consultant for Toshiba. I've been with the company just over 10 months now. Prior to that, I've worked for LNER, GB Rail Freight, Stagecoach, Chiltern Railways, and Network Rail, all in the railway sector. 15 years, as Kuldeep says, of that has been ostensibly in the weird and wonderful world of timetabling and train planning. So I'm not a computer person by trade, so please be gentle with me on the questions. I'm a train person by trade, but hopefully I'll be able to bring the two together today, and you'll be able to understand how the two can work and interrelate, and what benefits it can bring to the industry. So if you just bear with me a second, and I will share my screen. And if people can tell me when they can see what I can see.
We can see you, Paul. We can see the screen, Paul.
Yeah. Okay. So today's webinar is entitled Digital Twin Based Robust Train Planning Approach, and our philosophy here, which is prevention is better than cure. So today I'd like to give you all a bit of a background into how digital twin technology came to be, which will then help paint a picture of where it has slotted into the train planning industry. I can then go and touch on a few use case scenarios and summarize where digital twin we see it in the future. So a brief overview to start with. Forgive me if I'm taking some of Ian's thunder away here, if he's got a similar background slide. So digital twins' origins lie, as Kuldeep said, in the manufacturing industry, and it has been rolled out into other industries following its initial success there, such as social infrastructure and the energy sector. An example of the latter has seen this technology used to optimize the energy plant operations of several large organizations. Very simply put, it takes real-world data and scenarios, transporting that information into an identical digital environment where independent simulations, evaluation, and subsequent optimization can take place, and then these results are fed back to the real world. Toshiba has developed digital twin technology ourselves in all of these fields. And digital twin technology has many unique advantages, but we've grouped some of them here together just into 3 sections. So it can simulate the future in advance. So with a digital twin, we are able to set future data values that currently do not coexist in the real world. And in trend planning terms, this will help us visualize the future, which is quite often hard to do with such a complex thing such as a timetable, and be able to conduct a variety of simulations on these future data values and scenarios. Digital twin technology offers a flexible approach for collaboration. This is a big buzzword at the moment in the railway industry for train operating companies, infrastructure providers like Network Rail, and governmental bodies to all work together. And digital twin enables this on a independent third place cloud platform. So it therefore becomes relatively easy for collaboration to occur by allowing other entities and operators into the cloud-based environment without affecting daily operational planning systems which exist in the industry. And then the use of artificial intelligence. So this is a big USP for digital twin. Many industries have started using AI technology to optimize their operations. However, it doesn't fit very well in an analog world, as I'm sure you know. So the data needs to already to be digitized. So digital twins platform enables this use of AI. And it will be very significant in adapting the planning process in the future in the railway industry. So bearing in mind my audience here, I appreciate that people here are not necessarily from a railway background, so it's probably wise at this point to give a bit of a background into some railway terminology that you'll hear me saying throughout this webinar. So train planning is full of specialist terms. So I'll just go into a very few here, which you'll hear throughout this webinar. So we talk about timing points. So these are locations on the railway network, usually junctions, signals, or stations where trains are scheduled to be timed or recorded at. So these aren't necessarily what you might see in a paper booklet that you pick up at a railway station. They can be a lot more detailed than that. And we divide these timing points into what we call mandatory or conditional. Mandatory being everything times there, conditional being trains time there if they perform a certain activity. I'll also be referring to things called SR. Oops. Apologies about that. I just somehow got muted there. I didn't press anything. Right, sorry. TRTs and SRTs. So technical running times and sectional running times. These are expressed in multiples of 30 seconds because unfortunately the railway in the timetabling sense isn't as granular as you may think it might be. Even though TRTs are calculated to the second, sectional running times are then rounded to the next 30 seconds. And this is the time that it takes for a train to travel between two timing points, as I've just previously explained. Factors which would affect this time taken could be things like line speed, the weight of a train, its type of train, distance, braking capabilities, etc. So a headway. So a headway, in its simplest terms, is the safest distance expressed as a minimum time interval between two successive train movements at a given timing point on the same line in the same direction, based on signals being green. So effectively, it is a raw technical value expressed in seconds, and it's a way of expressing distance in terms of time. For train planning purposes, these values are also rounded to the nearest 30 seconds. I'll refer to junction margins. So as we know, the railway is full of junctions where trains cross onto different tracks. So a margin at a junction is the safest distance, again expressed as a minimal time interval, between two conflicting train movements. That can be in the opposite direction or in the same direction, but on the same line, but can only be on the same line if the two train movements are converging or diverging. So the second train must be able to meet its SRT, which I've just explained above. Again, these are raw technical values expressed in seconds, but we would round these up to 30-second intervals for train planning purposes. And then I'll make reference to something called a diagram. So a diagram in railway world is not a piece of paper with a drawing on it. It's actually a chronological list of duties that a train performs throughout its day. And we can also talk about diagrams in relation to train crew as well as rolling stock, i.e. the actual trains themselves. So the structure then of the train planning industry. So we have what's called TOCs, train operating companies, and FOCs, freight operating companies. Both of these have what's called train planning teams, and these teams essentially bid for capacity on the network. The network being owned by Network Rail, who then has to manage this capacity by bringing all these bids together and by a code of conduct which it is bound by, distributes this capacity as fairly as is possible. And the end result of that is, in a perfect world, an integrated and fully validated timetable, which is then offered back to the TOCs and FOCs. There's then some form of exchange of remedial alterations before the actual physical timetable, which you see when you catch a train, actually physically operates. So the timetable is constructed on a set of rules, which are referred to as timetable planning rules, and they contain within them all the parameters for the safe operation of the railway and the high performing nature of the railway, by specifying the minimum time between train movements, as we've said on the previous slide, referring to headways, junction margins, SRTs, etc. And this allows construction of a plan which can run which can be then controlled on the ground by the operational railway staff in a safe and performance robust manner. We also refer to timetables in broadly two contexts: LTP, which is the long-term plan and is what we call a baseline timetable, and then we have a short-term plan on top of that, which is variations to the baseline timetable. These can be brought about for many reasons, such as commercial changes. COVID has brought about a lot of short-term plans, for example, as well, and engineering works requiring diversions to services. We all know about rail replacement buses and that kind of thing when the line is shut and trains terminating in different locations. And all that follows the same process as outlined above. I won't dwell too much on this slide, but this basically shows you the time scales from when you have to start planning a timetable to when it actually physically starts to begin. So as you can see, a timetable commencement date on the, if you look at the principal change column at the very bottom, so the timetable that started on the 12th of December, or will start, sorry, on the 12th of December this year, that planning for that started last summer on the 17th of July. So it does take a long time to bring a timetable together, and all the various things that have to happen along the way to do with rules and draft timetables, and lots of consultation between all the train operating companies, freight operating companies, Network Rail, and various other stakeholders. So if we now try and bring section 1 and 2 together, so how will digital twin help in this complex world of train planning and timetabling? Well, this slide I could have actually updated today. As you may have seen on the news, there's been a bit of an announcement today in the railway industry. We're almost going back to the days of British Rail. Well, they're just putting the word great in front of it and calling it Great British Railways. And that is essentially the birth child of a review which was originally entitled the Williams Review, but Mr. Grant Shapps got involved in it, and now it's called the Williams Shapps Review. So this came about by some unfortunate recent history which scarred timetabling and train planning, which, if you may remember, back in 2018, there was a big national timetable crisis, but that particularly hit the Manchester area and London more so than other places. Why did this happen? Well, there's too many demands at very short notice put on the industry. The industry at the time was operating under a franchising system where companies such as Stagecoach, which I used to work for, would often bid unrealistic and undeliverable timetable bids, basically to suit a very rigid specification from the Department for Transport. And even though that some of these companies knew that their bids were untenable, they had to do it because otherwise they didn't meet the criteria and therefore they wouldn't win the tender. But then when reality hit, quite a lot of these bids could not be delivered on the day operationally. It was all just a paper exercise. The crisis, in my opinion, had been quite a long time in coming. Train planning has never really been given the importance and respect that it deserves as a complex kind of job. Quite often it's seen as an administrative job, and the Williams Review has ended up being a byproduct of this chaos. The review in its structure was to look at the whole structure of the industry and how passenger services are delivered. Recommendations for reform obviously have now come out to prioritise passenger and taxpayer, and this was conducted by Keith Williams, who is a former deputy chairman of John Lewis Partnership and a former chief executive of British Airways, and then obviously Grant Shapps, who is the transport secretary. So in the real world of train planning, it's not really a great secret, and from my own personal experience, that there's a number of challenges faced on an almost daily basis, of which have only become more challenging as the years have gone by and as demand for more frequent, reliable and punctual services has increased, and the operational pressures out there in real time have undoubtedly filtered down to the world of train planning across the industry. And here we've identified 6 areas where we believe the challenges can all be grouped. As you saw on a previous slide, it can take over a year and a half to plan a timetable. That seems like a long time, but when you get down to when trains are timed to every 30 seconds across the entire country, at many interacting junctions, you start to think that that's actually not a very long time to go through such a massive task with multiple iterations. something that's arisen and possibly caused the May 2018 timetable crisis is a demand for increased complexity to these timetables. So people now want to have direct trains between everywhere they travel, but that in itself creates complexity instead of changing at stations where trains might operationally be better off going to different places. There's still a heavy reliance on suboptimal manual processes within the industry. I've worked in the last 5 years in organisations where pencils and rubbers and rulers are still used to construct train plans and diagrams. There's a lot of change in the industry itself, not necessarily in technology, but certainly with political change and change that brought about by things like COVID. Timetables are always rewritten to keep up with the demands of the travelling public, but it's not a 5-minute job to write a timetable. So the change, the perpetual change that we've seen in these last few years has undoubtedly caused many problems. So what is kind of relevant to technology is the industry is full of data, whether that be performance data, train running data, or data from signals, but we don't always interpret it in the right way. Sometimes a lot of systems rely on the data being correct to start with, but if that is wrong, then by the time you've got to the output, what you've produced is of no real great value sometimes, and there can be quite a lot of discontent between train operators and infrastructure providers where this data has been interpreted wrong and is then imposed on a company's baseline revenue. And then the good old capacity performance versus trade-off. This is something that the railway is always balancing, and at the moment we're shifting far towards the performance side of things, with the Department for Transport mandating that we build the railway back better. And now that we've got less people travelling right now, although demand is slowly picking up again, we should focus on getting the performance of the railway right, whilst maintaining the fact that we know we need to protect capacity for the future. So at Toshiba, we see ourselves right at the start of this process. The railway quite often gets caught up in a do, check, action whirlwind, and you cannot prevent an event or an operational function from happening that has already occurred. You can only prevent it from reoccurring. Otherwise, you're just curing the problem. Therefore, to avoid the vicious circle that I've just described, we must look to prevent at the planning stage to minimise the risk throughout the plan, do, check process, so that any remedial action is either minimal or, in a perfect world, nil. So, and it is a given that we must feed a timetable into the plan stage, whether that is an existing one or a historical one, in order for the simulation and analysis to begin to prevent this future failure. So digital twin, we believe there's only one place for it. If you understand your situation and your known risks, then you can prevent them. So as we've said on a previous slide, we can simulate the future in advance, a flexible approach for collaborating, and use of artificial intelligence. This will help us understand and unlock the potential capacity of the railway, and therefore understand what we can and can't run, and therefore what will perform good and bad. We can look at what if based scenarios. The railway loves to optioneer and loves to go through as many options as possible to try and find what could be the best commercial, but also the best operational timetable. And we believe AI will extend the natural knowledge of planners like myself and core competencies, because it can think in a way that we might have some preconceptions. And this sort of expands on the very first slide where we showed the real and cyber worlds next to each other. So we take all the components of a timetable, the timetable planning rules, future-based scenarios, local rules and regulations, etc., throw them all in to the digital twin, and then we can calculate accurately and to a very granular level, accurate SRTs, TRTs, headways, junction margins, the performance characteristics of the rolling stock. We build the infrastructure digitally, as you'll see in a couple of slides, right down to the nearest. The railway works in miles and chains, not in kilometres or meters, unfortunately, but right down to the nearest mileage and chainage of every piece of infrastructure. Then we apply some of our unique AI and our delay risk evaluation methodology, again, which we'll talk about briefly later. This then produces an optimized train plan, which we then feed back into the real world, and then abracadabra, we should have an optimized train plan. It's fair to say at this point that there are other simulation systems in the market, but digital twin is very unique, and we're looking for it to complement these systems, not act as a replacement. So now, without getting too bogged down in detail, we can briefly go through some use cases of digital twin in the railways. Our full scope of what we can do is sort of illustrated by this diagram, but it all harks back to having a base timetable and the associated rolling stock and infrastructure. Without that, we can't move into the green, blue and pink areas. And here we have what I call an under the bonnet look at our run curve simulator. So this is where we gather all the infrastructure data from Network Rail as much as we can. We go to the rolling stock manufacturers to gain the performance characteristics of the physical type of train that we're looking at. So that's all the physics of it, its tractive effort curve, its weight, its running resistance, its braking capabilities. So all the engineering physics side of how a train actually gets on the move. And we combine them together, and this is what we end up with. So what we can see here in very layman's terms is the speed profile of a train going up and down, red being when it brakes, green being when it accelerates, and the turquoise being where it hits line speed. That's what the grey rectangles are. Those are the varying speed limits of the route, and this is from a real life example that we've done with our client, Greater Anglia, which is a TOC based obviously in the Anglia region, southeast of the UK. And this is between London Liverpool Street Station and Angel Road. So this is a real example. As you can see here, these are the various signals on the route, and we've got curvature, tunnel information and gradient information, all of which will have an impact on the performance of the train. And from this, once we've got all our run curves built for our various types of rolling stock on the relevant infrastructure, we can import an existing timetable or indeed a future one to start looking at not just one particular run curve of a train, as you saw in the last slide, but many hundreds of them which make up a timetable. And these are what you can see down here in graphical format on the left-hand side, with locations running from London up towards Cambridge. We can look at timetable conflict detection. So the red little blobs are where two trains are theoretically too close together, and the signalling cannot support those two trains running so close together. Trains I should have probably said earlier that trains are actually planned to run on green signals. We don't tend to plan trains to run on less than green clear signals, because as we've said, we want a high performing, robust timetable and railway. And from the viewpoint of evaluation, we would look to improve delay risk. We would look at the frequency of the trains in the timetable, and if that is having an effect on performance, we would look at maybe journey time reduction, connectivity, and speed standardization. Here as well, we can look at what we would call conflict-free timetables. So that's where we bring together multi-operators who may share the same railway infrastructure and tracks, and bring their timetables together to see how they actually work as one. And this is, again, this is a slightly more blown up version of our conflict detection functionality. So we can have the ability to edit timetables where we have spotted conflicts. This can be to do with track occupancy, insufficient headways, which we've explained what headways are originally, clashes on single tracks, two trains heading towards each other on the same track, and overtaking between stations and other scheduling errors. And some of the work that we're doing with Greater Anglia, we've passed the proof of concept stage with it, is looking at maintenance of trains and how that impacts on the ground performance and operations, and ultimately the timetable. So here we would go to the relevant train operating company and get as much information about one of their maintenance schedules and the actual physical depot where those maintenance schedules occur. We would look at their inspection routines and their shunting procedures within the depot. And the output generated from this is a depot shunting timetable, which actually intertwines with the actual mainline operation out there on the network. And we can look at sequentially making train movements a lot more efficient. It allows us also to have the ability to schedule depot planning in the correct order, so that trains make it onto the network at the right time and therefore fulfill the timetable. And we can also look at minimizing conflicts outside of the depot once trains hit the main line. So to summarize where digital twins place is and where it will be. So right now we're planning for the future, and we are not trying to remedy the past. We plan early, we need to plan accurately and holistically, and this will have massive downstream benefits. And if we plan to prevent and don't review to cure, we will improve performance, mitigate risk, and ultimately improve safety. And we will have happier passengers on a better performing railway. We look to optimize, evaluate, and analyze as we plan. Then we do check and action. This right now is the moment to seize the opportunity, not just through the news today of Great British Railways, but also COVID has presented the industry with an opportunity to take a whole new look at itself and its processes. Now that performance is especially in the spotlight, and as we've shown, we offer the ability to collaborate on a digital platform where TOCs and Network Rail and FOCs can all solve their challenges together. We have a changing railway more than ever, and we need to realise the potential of the network, but for both performance and capacity. The future is changing, and we must be dynamic and not as constrained as we were before, and face having another May 2018 on the horizon, which the industry cannot afford. Technology such as ours can optimise, and COVID has brought about the uncertainty. Historic data at the moment now is starting to become more meaningless, as our railway is totally different now with people travelling and volumes of and frequency of trains. So simulation has to be the way forward. And as it's the evening, we can end on a funny quote, which is from Keith Palmer, the head of performance and planning at Abellio Greater Anglia. He said this to myself, and I believe Kuldeep was there as well, and my manager. He said, working in train planning is like baking a cake. Everybody likes the taste of your Victoria sponge, but somebody always questions what flour you've used. And I couldn't have put it better myself. So thank you for listening. And if we're doing questions now, then please feel free to leave some, or we'll wait till a session afterwards. Thank you.
So, thank you, Paul. Really interesting. We now know if my train at Manchester or around Cambridge is delayed, who to call. But no, all in all, quite insightful session. It was good to get in grips with what digital twin within real world looks like. We do have a question. So what, in terms of the format of the session, we're going to do a few minutes of question answer round, and then we've got Ian who's going to talk to us about digital twin within Highways England, and then we'll have question and answer rounds after that as well. We've got a question from Ender, and he's basically asked about the frequency or as to how often is digital twin updated with real world data?
That's a good question. Effectively, we need to keep it as up to date as possible. So what we have done with Greater Anglia is every time that there is a timetable planning rules, so a TPR document issued, then that will contain the new railway geography of the nature we can use it. So we would update that at least 4 times a year. But if we know of something big that's on the horizon, or something directly from the TOC that says, well, have you heard about this new crossover or this new signal that has gone in, then we would look to get stuff direct from the TOC if we know about it as well. But as I say, we are heavily data reliant on Network Rail, who own the infrastructure. So
the answer is as often as Network Rail allows you to, in a way. Okay, thank you. We've got a second question from Lester. So Lester's asking, how long does it take for the simulated data to feed back and be implemented in the real world?
So almost instantly. So once we've conducted our analysis in the digital world, then yeah, we would feed that back in sort of an output from our system, and then that is compatible as a data exchange to then plug into, for want of a better word, one of the systems used by either Network Rail or the TOC. So, and we produce, because we are a consultancy as well, we produce PowerPoint reports which contain the data in at least a text format for our end results.
Perfect. Okay. Yeah. No, thank you. We've got a follow-up question from Lester, and that's timetable changes as well. So basically, his initial question was, how long does it take for the simulated data to feed back and be implemented in the real world? And what about the timetable changes that you've proposed? How long would that take to be in effect?
So that would have to follow industry timescales, which is something we can't control because we're not a TOC. We sit outside the industry. So if we were, it would depend on the timetable and when we made those proposals. So, for example, if we made some proposals tomorrow for the earliest timetable we could do that for would be for December 2021, which would begin on the 12th of December. And it's essentially we would hand that across to Greater Anglia, and they would have to hit their various industry timescale as to when that could go in. So if it was timetable planning rules changes, then we're not talking December 2021, we're talking May 2022. So in that example, what we produce tomorrow, you wouldn't see in the real world until another year.
Perfect.
But that is just a particular, that's nothing to do with our technology. That is that's just industry timescales, which unfortunately we can't influence.
Yep. Yep. Thank you. I think that answers that. So it's basically subjective to the clients that you work from. Okay. No, thank you very much. Really interesting and insightful session, Paul. What we're gonna now have Ian tell us about digital twin within highways. Hi, Ian. Can you hear us? Okay, we can all see you. Yeah, I'm just gonna make you the presenter now. You should be able to share your slides as well, Ian. I think you're on mute, Ian. We can't hear you.
Do want to unmute myself? There we go. I'm not used to. This is a very complicated conferencing platform.
I agree.
So yeah, apologies for that.
It's not your fault. I think it's yeah, it's a sort of yeah, not the usual choice of seminars. So
yeah, let me just see what I can do. Let me see. Is that showing anything?
Yep, we can see your presentation now.
Okay. Okay. Well, I'm glad that part works. All right. Yeah, great to be here. Sorry for the technical difficulties. I blame Highways England. Very locked down computers. It's very difficult to do anything on them. So there you go. But I probably shouldn't say that. So yeah. My name's Ian Gordon. I'm the head of data architecture and engineering here at Highways England, which I usually describe as I am the data plumber for the organization. So there's a whole lot of demand out there in the business to do new and novel and interesting things with information, or at least do semi-intelligent things with information. And I'm trying to make sure that we become a data-driven organization without creating too much redundant infrastructure. So how can we create a common set of data platforms that allow us to manage and make use of our information as effectively as possible, and which ultimately would provide or should provide the underpinning for investment in things like data science projects and probably most relevant for tonight, digital twins. This slide pack is an evolution of a slide pack that I've presented both internally and externally at Highways England to really sort of, as it says there, try to create some consensus around what it is we're trying to accomplish in this space. I think, as with any large organization, there are always a lot of different projects happening in parallel. And I think, ultimately that's a good thing. But to go back to the plumbing point, we want to make sure that, that's a good analogy. Everyone can have their own different power shower and jacuzzi and sinks and other things that use water, but you don't want to have 50 different pipes coming from the mains. You want one mains pipe, and then you can redirect the water to all those different use cases. I think that's a bit of a theme that you'll see in this presentation. It's kind of intended to be a kind of warts and all. How do we actually sort this out and put this into practice? Certainly in the highway space, there's less of the existing practice that you saw from Paul there, where simulation, modeling, that sort of thing has been done for many years. This is a little bit more of a blank canvas, if you will. Clearly, there has been transport modeling in the highway space, but I think we're trying to take a more organizational view of things. So, without further ado, what are the things we're trying to talk about today? As I say, building consensus, providing a little context around where we think the opportunities are for use of digital twins in the highways. Because this is a BCS presentation and because I'm a data architecture person, a fair bit of detail on kind of the data architecture challenges that we're trying to we're trying to address. A little bit about ontologies, because that's something that's quite exciting, and then a question around what's our shared vision and how do we apply ethics to this space. So I will canter on because there's stuff here. It's a picture of some roads. Look at that. So in terms of building consensus, I think the first thing that we're trying to do is just make sure that everyone's on the same page as to what a digital twin is. I think for some of you that might seem like a very obvious thing, but this is still a relatively hyped term, and I think depending on where people are coming from, whether they have a BIM background or a transport planning background or a strategy background or whatever, asset management, they will all have relatively different concepts of what is and is not a digital twin. It's quite useful to have some imagery that just kind of details kind of what that might look like in practice. So the working definition that we have is it's a digital representation of a physical thing and its operation that can be queried. I think most of that definition is stolen from other places. Well, let's be honest, all of that definition is stolen from other places. But I think it covers some important bases. So first of all, it establishes that a digital twin isn't just a BIM model, which is important in the construction space. And I think it sticks a few key distinctions in there. So yes, we're talking about physical things, but we're also talking about how one operates the physical things. That obviously came out very well in Paul's presentation. And then the question about, or the statement that it needs to be queryable. So it's not just a nice picture, it is actually something that you can interact with. Whether that's real time or historic or whatever is kind of by the by. So that's our working definition. And then we've sort of been, as we've worked on our digital twin policy, we've tried to think about, well, again, what is this actually going to look like in practice? Like, what are the kind of applications? And I think this matrix, whilst not entirely perfect, sort of shows that it's unlikely that Highways England or any organisation of our scale will have a single digital twin, albeit, as discussed, the plumbing should be consistent. But actually, we'll be looking at digital twins that sort of exist on this matrix here. So on the left-hand side, you've got kind of the degrees of sophistication, right? So going from just, have we got all the data in one place and can we look at it, through to robotic process optimation and simulation and that sort of thing. And then on the x-axis, if you will, we've got different parts of the life cycle of our assets and of our organization. The implication being that you will have multiple digital twins. They will slot into different parts of this matrix, and as it shows here, some digital twins will go across silos, but it's unlikely that you will get one twin that just covers the whole matrix. And I think that's a useful way of framing the projects that we do and framing our investment. You know, where on this matrix are we trying to address particular problems, and how do we make sure that we don't end up with multiple twins that are occupying the same square in that matrix, which, you know, has happened elsewhere. There's another picture of some roads. So in terms of context, like, again, a big part of setting the narrative is really spelling out in layman's terms, or semi-layman's terms, what it is that one would actually do with these things. Because, you know, the people that hold the purse strings aren't generally going to be as automatically enamored with these concepts as we are, right? So, you know, you need to be able to express in, you know, important person language why they should be worried about this rather than worried about something else. So some of the use cases at a very high level that we're hoping to address, again, reflected in that previous matrix, are more sustainable and efficient construction, obviously. So taking the BIM platform and turning it into more of a project planning construction platform, trying to automate a lot of the manual heavy lifting that goes on in the data space there, you know, on most projects to this day. I think HE's rapid engineering model is a particularly good example of trying to create some functionality in this space. asset management, got to have asset management. So, you know, that ties into the predictive maintenance space. How do we move from being an organization that goes and looks at assets on a particular, you know, schedule to one that actually responds to changes in the observed performance of assets? So obviously that gets you into the IoT space very quickly. The one that I'm personally most excited about is making operations more resilient. Like Paul, I've spent a lot of time in the railway industry worrying about delays. And, you know, my observation, which is a pretty obvious one, is the scale of a problem is often as much down to how people react to the initial trigger as it is to the scale of the trigger itself. So certainly when I was in the performance teams in NetRail, you know, you could have two very similar looking issues, you know, a point failure, if you will, but how the organization responded to it, along with the context around what time of day it was and what the weather was and whether there was events were going on and that sort of thing, could be the difference between a point failure that delayed one train versus a point failure that shut down an entire mainline station for a day and cost millions of pounds in delay payments, which I appreciate isn't a thing anymore, but it was a big problem at the time. And obviously there's an analogy in the highway space, you know, things break down in all sorts of unpredictable ways on the highways network. People tend, in the absence of anything else, to respond based on experience and heuristics, which is usually a pretty good start. But how can we augment that decision-making process to say, you know, we've had an HGV failure on this junction. We believe that the best course of action is to slow down traffic 50 miles further down the road, do these diversion routes, you know, these sort of signals on the network, that sort of thing. I think that's particularly compelling. Forward planning, that's getting into your simulation side of things, which we've already talked about quite a lot. Interoperating with other organizations. There are very, very few journeys that start or end on the strategic road network. It's usually something that you use in between using local authority roads. So if we want to provide a holistic experience to our customers, we need to get better at working with them and stop treating what is clearly a single network as many different networks. And I think digital twins and the representation of those networks is important in that space. And then finally, take that to an extreme, bring the railway in, bring the other modes of transport, take your pick, drones, etc., and move towards mobility as a service, consuming transport as a means of getting from one point to another rather than, you know, using a particular mode of transport. So those are kind of our target use cases. And then the question is, well, how do we approach that as an informed client? So I think part of it is about building this common capability. There's a bunch of Highways England acronyms in these slides, so apologies if I don't explain all of them. But yeah, having a common data platform, ensuring that we continue to own and manage our own data, procuring outcomes, not just buying products, easy to say, hard to do, and then plugging into the wider community of practice that's manifest in the CDBB's National Digital Twin Program and elsewhere. So again, not just doing things our way, but actually doing things in a way that, you know, reflects the best practice elsewhere in the world. Another map. So getting into some of the specifics around what we need, what kind of the starting points are, and from an enterprise and data architecture perspective. The first thing that is quite important is, you know, information management. It's not a particularly sexy topic, but it is the thing that's going to make or break digital twins. So if you don't manage your data properly, if you don't have a way of ensuring it is of sufficient quality, if you don't have custodians of that information and security parameters to manage that information within, then it doesn't really matter what you do with your digital twins. They're not going to give people the value that they need to give. So we have an information management system. It's not particularly exciting, in my opinion, at least, but it's there to cover the bases of, if you want this exciting shiny carrot of simulation and prediction and, you know, all the minority report stuff. You actually have to do the groundwork to get there. And in many ways, digital twins can act, and these kind of exciting concepts like data science as well can act as the Trojan horse for getting your information management system in there. It's much easier to make a pitch to invest in these areas if people know that they're going to get something shiny out of it rather than just some data governance. And the common platform is another key thing. So we've unimaginatively called our common platform data as a service, and it is very much trying to create this view in the organization that data is something that should be available to staff across the board, rather than something that's siloed away in legacy systems. So we almost want to breed an entitlement to data within our staff, obviously within the limits of information access management and that sort of thing. And we want to be able to provide easy ways for staff to be able to start building on common data sets within the business. So on the one hand, we're busy beavering away trying to get automated extracts from all of our old legacy systems that are sketched across on-premise systems and proprietary systems and blah, blah, blah. And on the other hand, we're trying to stop people in the business going out and buying more bespoke data management solutions when they should be using the corporate solution. And the hope is if we can get all that data in one place, then we can make it available to lots of different products, including digital twins, rather than outsourcing all of our data ownership to the supply chain. At a very high level, extending that into, well, what does the data basis for a digital twin look like? If to BCS audience, it's going to be really simple, but, you know, consistently go back in conversations within Highways England to, are we talking about our data definitions, our schema? Are we talking about the data collation, or are we talking about applications? Because very often people buy vertically integrated stuff. They don't think about what's the plumbing that needs to make this work. They're just like, I want one of them, that looks fancy, give me one of those, and I don't really care about all of the details behind it. Whereas actually what we're saying is we want those bits in blue there, the schema and the data, to be Highways England, to be, you know, owned by the public sector, and then we want to be able to pick and choose the best applications to use on the basis, on the back of that. And again, there is recognition that we're going to have to build on sort of better ways of managing information, e.g. graph databases, rather than relying on
Hi Ian, I'm sorry, we can't hear you. We lost about the last 10 seconds. It's gone on mute again. I think you, yeah, let me just try and.
hello, sorry, my phone hung up on me, and then I was muted. All right, I'm back.
About last
so yeah,
10 seconds of it.
Yeah, I was just saying graph databases. That's what we need. Can you still see my screen?
Yep, we can see it. Okay.
Okay, good. Okay, and we'll touch on the underpinnings, the ontology, in a second.
Yep.
Let's just get to the next slide. So the current situation, I just like this diagram because it kind of shows how complicated these things get when you look across a large organization. So the current situation is we have lots of different databases that we use to collate information. You can see some of them there. And it's never really obvious where the primacy or where the single source of truth exists. So what we're trying to get to is a more structured approach to this, where we collate the information once, maybe twice, just to reflect the kind of different business models within the organization, and then we push that single source of truth out to the use cases on the right, you know, digital labs, digital twins, spatial analysis, standard ways of visualizing information on top of that common data set. And particularly excitingly, try and push that information out to third parties as well. So make sure that we are an organization that surfaces as much information as possible as we can get away with, really, to the private sector, to academia and stuff, because I think some of the best digital twins will probably be developed on our behalf by others. It's a lot cheaper for the taxpayer as well if you do it that way. And you know, it's just an example of creating that pipeline and sort of identifying that flow from what are the legacy systems, where do we need to go and get this data, where can we structure it in the corporate environment, how can we then work on it to deliver use cases to the business, and some of which will begin to border on kind of nascent digital twin use cases such as predictive maintenance and automation of particular aspects of our business. So that's the flow that we're trying to build in the business. And at least in my view, you do that incrementally. So you get into the habit of identifying these use cases and delivering the right data to meet them, delivering the right data science techniques, the right simulation techniques to realize those. And, you know, rather than going out and saying, let's just build a digital twin of everything and hope it works, you incrementally get to the same point by working up that kind of maturity axis that we saw in the matrix earlier. So having a really good machine learning driven data model to talk about how to predict, to analyze how roadworks get delayed and that sort of thing is the precursor to then having a digital twin that tells you proactively where you should be scheduling roadworks. That's the idea. At least that's my idea. And then driving all of that is making sure we have the rigor of creating common sets of definitions. So we don't just get all the data in one place and assume that a miracle will happen. We get all the data in one place, conform it to a common set of definitions so that you don't have to be an expert at all of the different legacy systems in order to derive value. The data is available to you in the lexicon that you are comfortable with. You don't have to be an Oracle expert and a confirm expert and a Maximo expert to start building digital projects and digital twins that combine financial and asset management information. The data is presented to you in a common standard lexicon of money and assets and that sort of thing. It's the sort of language that we use all the time. The challenge with ontologies and graphs is they get really bloody complicated really bloody quickly. This is a picture of our ontology zoomed out. This is only intended to be a very high level ontology of the organization, kind of covering 80% of what we do. But it's not something that's accessible to normal human beings, and therefore it means it's not going to be reviewed by SMEs and people that actually know how things work in practice, which means it will never reflect reality, which means we won't get value from it. So the challenge is having this digital ontological underpinning of our thinking, but surfacing up that for review in a way that's actually palatable to normal people. And we've begun to make a start in that. So we've created a sort of deliberately white labeled tool called Ontopop. If you go to ontopop.com, you'll be able to have a play around with it. Why is it not called the Highways England Ontology Visualization Tool? In the hopes that if this is something that's useful, other people will use it, whether that's suppliers or other public sector organizations. Because it feels like as the world moves towards digital twins, this is going to be a common use case. Like, we have to have a graph database and it has to reflect how our business actually works. So hopefully we can all benefit from creating some common infrastructure there rather than everybody trying to reinvent the wheel in the same space. And there are other solutions out there that do similar things, but we kind of wanted a non-proprietary solution just to get things moving along. So what does it do? Basically, you can go in there and you can search through the entire ontology using Sparkle queries, but expressed in a sensible, accessible UI. So you can search for particular concepts like a digital twin. You can then focus down on the part of the ontology that refers to that particular entity that you searched for, and you can use that to have conversations with normal people in a kind of mind map format without them ever having to know that you're actually just looking at part of a graph database. So when you've got a map that's boiled down to 5 entities and 5 relationships, you can actually start to have a conversation about, well, does this look right? Is something missing? Are those relationships and arrows moving in the right direction? Should we add something else? And you can also start to explore, so you can incrementally add more entities and nodes into the view rather than just blowing everyone's mind and losing their attention in the first item. So it's kind of not entirely public, but available to people to play with if they're interested on the interwebs. And if you've got any thoughts or feedback as to how this could be useful elsewhere, you know where I am, basically. But yeah, go have a look. I think it's pretty exciting. But then I would say that. And that kind of ties into the bigger vision of how do we bring this kind of data architecture to bear to solve construction issues. So we've got a relatively large tender out to basically build what you're looking at now. So you've got that upper layer there of conceptual visualizing. How do we bring all of the different concepts that are floating around in our organization or expressed in different ways back to a common ontology, back to that common conceptual data model? And how do we then visualize that and make that accessible to people? You've then got that middle layer, which is the kind of more established practice of, okay, you're going to build a road, you should surface up an exchange of information, an employer's information requirements document, like a literal Word document, or surface up a work breakdown structure or a cost breakdown structure. At the moment, all of those artifacts are kind of use similar terms, similar concepts. If you're a person that's familiar with the industry, they will make sense to you, but they do not explicitly link back to any sort of common conceptual data model. Obviously, there are things like Uniclass and Kobe and so forth, but for their implementation within a particular organization, it's not like this EIR is a reflection of or a lens on the Highways England ontology, the Highways England common data model. It's done in isolation, and that's something we're trying to fix. And then obviously at the bottom level, once you've established those schemas tied back to the common data model, then you can start to conform your data in your systems to reflect that understanding and to make sure that as we build more applications, we're building on those common data definitions, which hopefully means that our digital twins will make sense, their outputs will be legible, and they will be built on business logic that actually reflects what the business does, rather than some hypothetical rule set that doesn't really reflect things in the real world. What else? And the last thing is, creating a shared vision. So it's all well and good for me to have these opinions, but really what we want is for this to be the organizational opinion of Highways England. So it's clear that A, this is something worth investing in, B, that we should do so in a way that conforms with these common definitions and this common architecture, and C, that it's clear that this is part of a bigger enterprise. It's not something that's done in little pockets in isolation. So what are we looking at here? Well, we've written a digital twin policy. If you're a member of the Digital Twin Hub, which you should be, I posted it there yesterday for review, so you can go in there and have a look. And within there, there's a diagram that I haven't quite finished yet, but tries to synthesize in a consistent way from the top down, what are the outcomes that we're aiming for here? How do we expect those outcomes to be realized through implementations of digital twins? So we know that there's going to be different types of digital twins for those different outcomes. And then what are the value streams that derive those digital twin implementations? So I've talked a lot about the data architecture and the information streams. So, all of the digital twins should be built on that same architecture. But there's also organizational and technological and process-based streams that then need to create the parameters for those digital twins to operate in. And it's only if you bring all that together and pair it with some sensible behaviors at a cultural level that we're actually going to get value from these technologies. Which takes us on to the final and potentially one of the more important, to me at least, aspects, which is how do we actually make sure that we do these things ethically and we apply them in the right way. There's a Stafford Beer quote, which you can see there. The purpose of a system is what it does. It's not about your intentions when you built it. It's about how it manifests itself in the real world. So we've seen that in all of the very well documented instances of algorithmic bias, and the very real consequences that those have for very real people. We're not at that point with digital twins yet. Digital twins aren't ruining anyone's lives just yet, as far as I'm aware. But if this technology is anywhere near as powerful as we expect it to be, then we're very quickly going to be in a position where the algorithms that we use to build our digital twins will be influencing real world events. And it could be, as the image here suggests, that we find ourselves in an equivalent of the trolley problem, basically using our digital twins to make decisions that where we're asked to make actual consequential decisions around those outcomes of people. It doesn't literally have to be killing people, but you know, when you start to think about how the many different ways that infrastructure affects the lives of people, whether it's pollution or access to opportunity or whatever, any sort of allocation of resources is going to be maybe not an entirely zero-sum game, but there's going to be optimums that have to be figured out, and we need to do that in an open and ethical manner, or we will do damage without realizing it. And that kind of ties into all the governance stuff, but I think it's probably broader than that. And I think, yeah, that's it. Look, there's a picture of Anglia, and yeah, it's been great to run through all of this stuff. I'm happy to take any questions. I think it's Kuldeep's turn to be on mute. It's a very complicated platform we have here.
It is, isn't it? The irony of it being a BCS event. No, really interesting talk. And very diverse as well. I mean, it's interesting how, you spoke about digital twin, but how important is it to consider about how it's embedded in an organization and how it communicates with other stuff as well. And I do like, I'm on Ontopop's website. I do like the idea of open source as well. So yeah, well done with that. And thank you. All in all, really interesting session. We're all glad. So we've got a few questions here, more than a few. I'm going to start with the first one, which came up during the session. Is there, in terms of software technologies used, what are the software technologies being used to develop the digital twin?
Well, I mean, so we haven't really grappled with the application layer to any great extent. So really, the data platforms we're trying to build using scalable public cloud solutions for the data storage. So we're in Azure. Other clouds are available. Trying to use platform as a service stuff wherever possible because it's just a bit easier and you don't have to worry about managing it so much. And then in the ontology space, we're using things like Sparkle, Apache Tinkerpop, Gremlin, D3, that sort of thing. Things that I don't actually understand but seem to work and I'm told are really cool. So, yeah.
Perfect.
And I think what's really interesting at the application layer is how do we avoid this becoming kind of a walled garden for individual vendors, as we've kind of seen in the BIM space. How do we preserve that kind of open nature to an extent?
I think which is quite important as well, is that when you've got to have a tool which is not focused on one thing, and I saw it in the architecture and diagram, which is quite good. Moving on to the next question. Is there an academic way to follow or be certified in digital twin? I think it's quite good that we've got Darren, who's the chair of BCS, and he is the head of computing at Manchester Metropolitan University. So maybe it could be a question for both of you.
Darren, do you want to have a go? Darren's very quiet. I didn't fully catch the question. Can you repeat it?
So is there any academic way to follow up to be certified in digital twin technology?
Not that I'm aware of. Maybe the university wants to do that. I think Darren's off mute now.
Sorry, again,
I'm sorry to put you on the spot there.
No, it took me a second to work out the buttons. I'm not aware of a particular academic qualification for it in itself, but there certainly is, it is something that's getting increasingly incorporated into many of our degrees, particularly some of our engineering degrees, where it's becoming a significant aspect.
Okay. Yep. So yeah, thank you, Darren. Hope that answers your question, Honey. The next question is the webinar being recorded? The answer is yes. It's going to get shared with the group and possibly get published on BCS forums as well. Yeah, got one from John. What is the top level ontology for Ontopop? Is it 3D or 4D? I suppose that's really
the old 4D question gets me every time. So basically, I'm waiting for the CDBB to figure that out. That's my answer. So we've tried to design our ontology so that it can be. So we started work on it a year ago, long before any sort of information management framework stuff came out of CDBB. So the hope is when they publish what their upper ontology is, we will be able to sort of work to realign to that way of working. But we wanted to get started and we wanted to keep it simple. So probably is a 3D ontology at the moment, but we're aware that that's not cool, and we're going to have to move to 4D once we have a suitable standard to work against. Stuff like 1596 is just a bit too complicated for me, so I need it to be a bit simpler.
Right. So it's within the horizon, but currently 3D. It's a sort of thing. Okay. You mentioned BIM. Is that used for modeling digital twin within highways? Question.
I mean, it's a question, can a BIM model be a digital twin? To me, a digital twin is just a step above that, right? Yeah. I'm not sure that I don't think you can interact with a BIM model in the way that you want to be able to interact with a digital twin. BIM to me is very much just a visualization rather than something that you can query. I'm sure there's lots of people that would argue that point with me, but I think we need to aspire to something bigger than just really fancy BIM models.
Yeah, I think digital twin would allow you to run simulations, talk to the real world thing. So no, yeah, agreed. That is thing. We've got a question for Paul. Is Paul still around?
I am.
Paul?
Yep.
Hey. So I read the question. I guess you must filter on your digital twin. I guess you must filter on certain kind of events, such as train breakdown, weather, etc. In order to use digital twin for timetable updates, could you talk more about data preparation or cleaning for these events, please?
So it depends on the remit of the project. So we have been remitted in the past to look at weather variations and what we would call adverse running, some motor failures, that kind of thing. But if we're looking at just a timetable, and timetables are planned to run in perfect scenarios, so we wouldn't take into account data that would be drawn from those adverse scenarios. Is this more related to sort of performance modeling, this question? It sounds like it.
It's related to planning against. I've unmuted the audience as well, so please feel free to ask any questions. But yeah, from just reading the text, it seems like more around planning around events. So say if there is a train breakdown or bad weather, that type of thing.
Okay, so that sounds like a more real-time thing. So if a train broke down in real time, we wouldn't necessarily. That's not necessarily where we deploy our technology. We work in a perfect world as opposed to a plan to fail world. Not to say we can't, but yeah, it's maybe that question is more in the context of something we don't offer, which is real-time kind of control operational scenarios.
Actually, I asked the question, if I may. So
okay.
The question is actually related to timetable planning, and you get your data from the real world to develop your timetables, but how do you determine what is the perfect scenario? If all the information actually comes from the real world, which is messy and has outliers and so on, how do you go about preparing that data so that it's good enough for developing your timetable? Thank you.
Okay, I think now I understand what you mean. Okay, sorry about that. So the data that we gather from, for instance, from rolling stock is how that rolling stock again would perform in a real world. So where we use to calibrate that data against things like GPS and OTMR, you're right, we do have to go through a cleansing process there, and that's one example actually. So when we look at the running performance of a train, that's exactly why we do get real world data and the so like some historical GPS data and some train planning data from the manufacturer, because we want to reflect the real world as best as we can, but we know to a degree that it doesn't always work as a perfect world in practice. So that's where the calibration comes in. In terms of filtering it out, or erroneous data, if we're talking about train performance, then that would still be done in quite a manual way. We would have to look at outliers, and that is still quite a time-consuming thing.
Any other questions? I think Ian, just I had a question about highways. In terms of, I think sustainability, and there's quite a lot of movement happening around carbon footprint and that type of thing. And you've got smart cars coming in, electric cars, connected vehicles. How would the digital twin help with that goal within highways sector? So is that now? I don't know. Are you thinking about that type of thing, or is it?
I think the thing that we can do to help the environment the most is obviously make it easy for people to switch towards electric vehicles. But with the best will in the world, I'm not sure there's a huge amount that the road operator can do in that space. And then secondarily, make sure that there is as little delay on the network as possible. So if we manage incidents better, that means everyone's moving a little bit more smoothly, and there's less petrol or electricity being consumed in the process. So I think the operational digital twins can have an effect there. If we imagine beyond kind of the present setup and into a world where we've got things like road user charging and fleets of connected autonomous vehicles and stuff, we could basically remove the carbon footprint of road transport in this country if we wanted to, but it would require a change in how we think about roads and the role that we expect the network operator to play in managing that. And I think being able to understand how the network functions as a system will be key to doing that properly.
Cool. Yep. Thank you. Yep. Any other questions? Last few minutes before we finish the session. I think
everyone's had a long day. I just think as soon as there's a master's degree in digital twins at Manchester University, sign me up. I'll be there. Looking forward to that.
I think it might soon be the way digital twin is sort of progressing in popularity. And it's amazing how many things, like we had before in Agile, we had Kanban that was taken from manufacturing industry, widespread thing, and now it's just, so yeah, sure. I think it does seem like the next thing forward. Nope. Okay. Seems like we're towards the end. No, thank you for your time, Paul and Ian. It was really interesting, and it was quite insightful to see how things are being done within railway, within digital twin, and what's been happening within highways, and how it's gonna, and the challenges of a big organization. Well, basically, so there's innovation, but then there's how do you embed it within an organization of that scale, and how do you get other systems to talk to it as well. So yeah, those are, yeah, it was really interesting to listen about that. So yeah, thanks for your time. I have sort of unmuted everyone, so if you could just give a round of applause for the speakers and taking the time out.
Yeah, thanks for having us.
I think there's a lag, but can you? Thank you, and yeah, have a good evening, all of you. Thank you.
All right. Thank you, everyone. Take care.
Take care. Bye-bye.
Bye.